Hello and welcome to Dr. T Math. In this video we're going to look at some pure math topics. Base 10, base 2, base 6, base 8, otherwise known as binary, decimal, hexadecimal, octadecimal, and so on. So what we're usually familiar with is base 10, where we're going to start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But there are other base systems. So there are different number systems. And most of us have heard of digital binary zeros and one, where in a computer or in any sort of power grid, a 0 represents off, a switch is off, there's no electricity, and a 1 represents on, meaning there's electricity. And so all these ones and zeros can be split up into bits and bytes. A bit would be one digit, or 1, 0, 1 state, on or off. And then if we got together 8 bits, that would make a byte. And then if we got together 100 bytes, or 1,000 bytes, that'd be a kilobyte. A million bytes would be a megabyte. But it's not really a million. It's not really 1,000. It's like 1,024. So it goes in base 2s. We just kind of round to 1,000 for a kilobyte. What we have here is 2 to the 0 power, and then we've got 2 to the first power, 2 to the first power, and then we've got 2 squared, and then 2 to the third power, 2 to the fourth power, 2 to the fifth power, 2 to the sixth, and 2 to the seventh. So if we wanted to convert between binary and decimal, then we're just going to take 2 to the first, second, third, fourth, 5, 6, 6, first, second, third, fourth, 5, 6th, and 7th, and then add all those together. If we got a 1, then we add that. So 2 to the 7th, for in this case, 2 to the 7th is actually 128, so we're going to add 128 for this 2 to the 7th. And then we got nothing for 2 to the 6th, so we can skip that one. And we've got a 2 to the 5th. 2 to the 5th is 32, so we're going to take 128 and add to that 32. We got nothing for 2 to the 4th or 2 to the 3rd, but we've got 2 squared, which is 4, and we got 2 to the 0, which is 1. And so if we added all those together, we'd get 128 plus 32 plus 4 plus 1, or 165. 165 if we were going in the opposite direction. Then we're just going to divide by 2 and divide by 2 and divide by 2 again, and look at remainders. So for example, 165 divided by 2, 165 divided by 2 is equal to 100, or it's equal to 82 and a half. So 82 and then a remainder of 1. Well, 162 divide by 2, 82, and then we're going to divide by 2 again. So we're going to get 41, remainder 1. And divide by 2 again, we're going to get 20, remainder 1. Divide by 2 again, we're going to get 10, remainder 1. Or sorry, we're not going to get 10. We're not going to get remainder 1 for 20 either. Remainder 0, and we're going to get 10 and 5, and then 2, remainder 1, and finally 0, remainder 1. So it's a little bit trickier, I suppose, for 165. Now, if you're just dividing by 2 and dividing by 2 and dividing by 2, there's a way to tell if that works out, but we want to find the smallest, we want to find the largest power of 2 that fits into 165, and it's going to be 128, which is 2 to the 7th. So this is where memorizing some of the powers of 2 really comes in. So you got 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Right, so given those, let's try a different number since we already know what 165 is going to turn out to be. So let's take, we'll do between 1024 and 2048. So we'll do 1,000, say 1,000, 1,215. Well, we know the nearest power of 2 is going to be 1024, so we're going to subtract 1024. And 1024 is 2 to the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So that's 2 to the 10th. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 to the 10th and 2 to the 0. So 2 to the 10th, we've got 1 in that one. 215 minus 1024, 1215 minus 1024. That's 191. 191. And so our next smallest, the largest power of 2 that goes in there is 128 minus 128. 128 is going to be 2 to the 7th, so we got 2 to the 9th, 2 to the 8th, 0, 0, and then at 2 to the 7th, we're going to put a 1 there, 2 to the 7th. 191 minus 128 is equal to 63. 63, just smaller than 64, so our nearest power of 2 is going to be 2 to the 5th, so we're going to have 0 for 2 to the 6th, and we're going to have a 1 for 2 to the 5th. 2 to the 5th, we'll get a 1. And so we're going to subtract from that 32. 63 minus 32 is equal to 31. 31 is just smaller than 32, so we're going to put, we already got a 1 for 2 to the 5th, so that makes sense. We're going to put another 1 for 2 to the 4th. Put another 1 for 2 to the 4th, so we're going to subtract 16. 2 to the 4th, 1. Subtract 16, we get 15. 2 to the 4th, and then 2 cubed, we're going to have an 8. We'll have 8. So subtract from 15, 8. And we get 7. So we've got 2 cubed, we got a 1. We're going to have a 1 for 2 to the 4th. Sorry, 2 squared, which is 4. Which will give us a remainder of 3. Let me clear out some space here. So we got 7 minus 4 gives us 3. 7 minus 4 gives us 3. And we're down to 2 to the first power. 2 to the first power is 1 minus 2 again gives us 1. And then we're going to have a 1 for 2 to the 0 power. So we're 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1 for 1215. That's binary. Another base system is hexadecimal, and if you have a computer crash, then you're almost certainly looking at some addresses in hexadecimal where it tried to move some bits and some bytes and some megabytes around from different addresses and they got stuck in a loop. And so you're probably looking at something like 2E5A F or something like that. Something with letters and numbers together. That's an address in the programming language down deep in the hard drive. These different addresses are basically like little compartments that have numbers associated with them. And it might look like, for example, 25F is 25F, but in fact in hexadecimal, what we have, just like base 2, this is 16 to the 0 power, and then this is 16 to the first power, and then this is 16 to the second power. And so we have 25F. We're going to do 16 squared, which is 256. 256. 256 times 2 is going to give us 512. And then we've got 16 to the first power. 16, we're going to multiply that by 5, and we're going to get 80. And then F, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then, sorry, we start with 0. 8, 9, and then A, B, C, D, E, and F. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits. And so we can compile numbers pretty quickly. If we go up to F for 16 squared, that's 16 times 16 squared, or 16 to the third. That's just in 3 units places, or 3 place values. Then f is going to be 15. It's just 1 less than 16. 15 times 16 to the first, which is 1, so 15. Add those together, 512. 512 plus 80 plus 15 is going to be equal to 607. 607. Going back the other way, let's start with a number that's fairly large. How about that 1215 number again? We'll do 1215. 1215. And we are going to want to know, again, 16 squared. 16 squared is 256. 16 cubed is 4096. 16 cubed is 4096. So anything from 256 to 4096 is going to be 3 digits. 16 to the first is 16, and 16 to the 0 is equal to 1. So 1215, we know it's between 256 and 4096. Let's divide 1215 by 256. We get 4.74. So 4 is our first value, and we're going to subtract from 1215 4 times 256. 4 times 256 is 1024, and 1215 minus 1024, it sounds familiar, is 191. 1024, so we're down to 191. Now 191 is less than 256 but greater than 16. We're going to divide 191 by 16. We get 11.9375. Now we can't say 11, so we're going to go A, B. B is 11. So we got 191 divided by 16 is 11.93. 16 times 11 is 176. We're going to subtract 176 from 191. And we get 15. And so then 15 is our last number. 15 is 16 to the 0 power times 15, so we're down at f. Minus 15 is equal to 0. So 4bf is 1215. All right, well, I hope that was terribly confusing for only a couple people, but I'm sure it's a little bit awkward using different bases. You could use base 4, base 10, base 7, base 2. Whatever number you can imagine, you can turn it into a base using the same type of rules, where you've got some number to a power is your new place value, and then you're just going to divide the decimal number, the base 10 number, by those powers of whatever base value you're using, and subtract, and then go to the next place value, and so on. Okay, this has been Dr. C's Math. Hope that was fun. Bye.